with expressions. Okay. So using those expression ideas, sorry. So using those expression ideas, now we're going to adapt it to story problems. So in these types of ideas, if you understand what's going on with the problem, sometimes the math falls into place for itself. And what I mean by that is, like take this problem for instance. Tickets to an amusement park are $35 for adults and $24 for children. Okay? So we're going to have people going into this amusement park, right? As we go throughout the day. And depending on the number of different people that are going into this amusement park, they're going to be different prices. So if we talk about adults, these are going to be $35 each time. These are going to be $24 each time. And when we do that, the business is going to add all those together at the end of the day to come up with some total. Okay? So what we need to do is come up with an idea to make our lives easier. So how can we calculate this stuff much quicker than just, okay, here's one person that came in, and then 30 minutes later, here's another person that came in. At the end of the day, we just want to know what? How many adults came in and how many children came in. So we're going to label those two things as A for an adult and C for children. So when we go to the end of the day, instead of having to add all of these numbers together, we're going to say, well, our adults, there were 100 adults. And then children, there were 50 children. So if we think about that, for each adult, it cost what? $35 per adult. And then we're going to add the 24 per child to get a total for our daily money that came into this amusement park. So when we're doing this, even though you're reading the story problems, really kind of thinking about it in a how do we solve this mathematical problem solving idea, come up with a solution that's easier than 35 plus 35 plus 24 plus 24 plus 35 plus 20. Like you could do that all day. Or we could just count the number of adults that come into the place and the number of children that come into the place and take each of those, times them by their proper amounts, and then add those together. And you could even just take this to find the adults' money and take this and just find the children's money. Okay, so you could even break this up even smaller if you wanted to. So there's a lot of different things once you understand how to use variables. Remember, variables are our unknowns because we don't know at the beginning of the day how many adults are going to come through. So our variables are these letters for the unknown numbers that we're going to get throughout the day. And this is our expression. And we have two different terms. We've got the adults and we have the children. So once again, using all that vocabulary, interweaving it back in so that we understand what each of these pieces is talking about, what it means. If you can start to get a grasp on that, it makes the rest of the math a little bit easier because you're understanding what's going on with the problem. And now we're just putting solutions to our problem. Okay, so let's take a look at this. What are you doing? Get rid of this. I don't want a title page. Please disappear. There we go. All right. And get rid of all my marks. Okay, so let's read this. Sammy buys some packages of pens and pencils. So I'm already using that mathematical brain. I just have done so many of these in my life. I know we're going to need to separate the pens and the pencil ideas. Okay, so she buys 5 fewer packages of pencils than pens. So let's talk about this. What do we want to label as pens? Well, I know this sounds a little counterintuitive, but if we're going to use P for both of them, that's not going to help us. So how could we use something different? Well, let me change the color, get some red in this. No, I just picked red. Come on, give me the red. There we go. No. Can I get some red? There we go. I'm going to use B for Bics. Bic pens. Okay, so we can even go Bic pens. All right, and there is no other pencil than a Dixon Ticonderoga number 2. So we will use a T for Ticonderoga. Okay, so when we start to think about this idea, what is happening? She buys 5 fewer packages of pencils than pens. So when we want to know, pencils cost $2.89 per package. Ooh, so now we can do this 2.89 T to get pencils, and pens cost $3.99 B to get pens. Okay. Now remember, an expression doesn't have an equal sign. We're just trying to write how this works. Okay. So once again, if she knows she's going to buy 5 fewer packages of pencils than pens. So if we talk about pens, we are going to take our pencils and subtract 5 from them. Right? Oh, no, that is not right. Let's rethink that. So no matter how many pens she buys, let's say she buys 10. What are my pencils going to be? Well, we know they're 5, but how do we do that? Well, you're going to say, well, we took 10 and we subtracted 5, and that's how we got T. But where did the 10 come from? What is our unknown variable that represented 10? That's B. Take away 5. So once again, we make mistakes all the time, and I'm going to leave it in to show you that even I make mistakes sometimes. So don't always get hung up on, oh, that was the right idea because it was the first one I came up with. It's got to make sense, though. Okay? So if we think about this in terms of like buying pens and pencils, use numbers. Sometimes numbers will help you. If I know I bought 10 packages of pens, then that means I only bought 5 packages of pencils, right? So how do I get that? Well, I take the 10, which is the number of pens that I buy, and subtract it from 5. So when we start to look at this, all we have to do for this expression right here is we have to take $3.99 times the number of pens and add it to $2.89, and we could put T, but we know T is what? B minus 5. So now all of this is just written with one variable in mind. So we don't need to know how many pencils we bought. As long as we know how many pens, we're golden. Now, could we do the flip side of that and do just pencils? What if we only know pencils? Well, we could. But think about how we would have to get, if I was given 5 pencils, how could I come up with 10 pens? Well, then I would know I would make T plus 5 to get to how many pens I have. So we could take this $3.99 and times it by T plus 5, because however many packs of pencils I have, I've got to add 5 to it to figure out how many pens I have. And I hope it doesn't get too convoluted for you. I know that's kind of tricky, but try and think about it from that concept. So if I know how many pencils I have, I will know how many pens I have by just adding 5. And if I know how many pens I have, I know how many pencils I bought just by subtracting 5. So they're just trying to connect those two things together, one way or the other. All right, let's go on to this one, page 3. Now, use your expression to find the total cost of a $49.99 item plus sales tax. The cost of the item is less cost of an item less a 20% discount. Okay, so let's do one where the item, and anytime you buy something, you're going to buy the item plus sales tax. Okay? Now, the item is whatever the item costs. So this will be the cost plus, and then how do we find the sales tax? Well, in Michigan, there is what they call a 6% sales tax. Okay? And how we come up with 6% is we have a decimal here, and we're going to move that decimal 2 places to the left. And anything that's open right there, like that little hump, needs to be filled in with a 0. So when we write this, we're going to write 6% as 0.06. Here you go, Schmidt. I already knew that. I assume nothing. I don't want to assume anything. So whenever I make videos, they really will start with the ground up. So here's 6%, 0.06. And what we're going to do is we're going to take that item and times it by 0.06. And that's how they come up with this idea of sales tax, is they take the item, times it by 0.06, and whatever money is there, that's what gets tacked on to the item itself. So when you buy that, whatever it might be, speakers or food, well, I would say pop, some things don't have a sales tax at all, but I don't want to get too deep into that. So if our item is $49.99, we want to add it to $49.99 times 6%, so that we can calculate the sales tax on top of our item, and we can put both of those together. So how would we do this without numbers? Well, we could say I plus I times 0.6. Now, if we wrote this with our coefficients in mind, remember, coefficients are the numbers in front of the variables. So this would be 1i plus 0.06i. Are they both the red flower? So is this variable the same as that variable? Can we combine these like terms? And the answer is yes. And all you need to do to calculate the item plus sales tax is times it by 1.06. So if we go and we're going to use our handy dandy Desmos, and we're going to times it by 1.06, you would see that the new price for our object is going to be, or our item is $52.98. So probably $52.99. They're going to steal every money, every dime you got. So there we go. And if you wanted to know how much the sales tax was, you could take that answer, $52.99, subtract your original item price, and you would know that you were paying $3 in sales tax. So just kind of connecting everything you can possibly do. All right. Now, I would love to tell you that the system doesn't cheat you, but I'm sure it does. And you can look at this idea in a couple different ways. And I'm looking at the next question, like a 20% discount. And when we think about a 20% discount, remember, things usually cost 100%, and we want to knock 20% off of it. So when we do this, really we are finding 80% of the value of the item as our actual item. And then, of course, remember, we have to add on sales tax. Okay? Now, once again, I would love to tell you that, and you have to kind of take a step back. If we were looking at the sales tax, would we still be paying $3 in sales tax? The answer is yes. Are we paying $49.99 for the object? No. Now we are actually going to make it a little cheaper by 20%. However, the sales tax still gets taxed on the entire item itself. I'd like to say that it doesn't work that way. Maybe it doesn't, but I'm sure more times than not, this is how it falls. But tinfoil hat theory there. So we have 0.8i here. And then remember our sales tax was 0.06i. So now we are going to do 0.86i. So 80 cents plus 6 cents equals 86 cents. I'm okay with that math. If you are, hopefully you are. If not, if we look at 0.80 plus 0.06, use the alignment method, and we can say 0 plus 6 is 6, 8 plus 0 is 8. Drop the decimal down in line, 0 in front, and that's how I get the 0.86. So let's give it a shot. Let's see what happens. So we do $49.99 times 0.86, and we get $42.99. So this item with a 20% discount would really fall under $42.99 as opposed to what our original was. Now use your expression to find the sales tax of $125.50 item. Well, we already have our equation right here with the 6% sales tax. So we don't have to recreate the wheel. All we're doing is putting in our new price and giving that new solution out. So I'm going to leave that one up to you. But just in case. 6 times 125.25, something around there. Wow. Well, that was for 25. Make sure you put 50. But that's the idea. Okay, last one. Let's get it. See what we can do. The number of gallons of water in a pool that already has 300 gallons of water in it, that is filling at a rate of 25 gallons per minute. Okay, so there's some things going on. Draw yourself a picture. I've got a pool. And there is 300 already here. And we can put gallons if we want. And then what's happening is we are adding to this 25 gallons per minute. So there's a rate there. So what could our expression be? Well, we started out with something. And when we think about that, it's what we call an initial value. There's an initial amount. So when I think of writing this equation, I want the initial amount plus the rate we're going to put it in. So our initial amount is going to be the 300 gallons that are already in there. And when we think about that, as time changes, yes, the amount of water in this pool is going to change. But when we first started out, there was an initial, like, hey, this is what's in there. And now we're going to add it. We're going to add to it. So that initial amount does not change. There's no variable next to it. Now, a rate definitely needs a variable. So a rate must have, I don't know, maybe must isn't the right word, but should have a variable attached to it. should have a variable attach. I can't spell today. To it. attach. Attach. I think that's how you spell it. attached. Attached. Yep. Okay. So I guess I need the ed on the end as well. Just because you're in math doesn't mean you can't misspell things. You do need to properly. It's just good practice. Attached to it. Okay, so we have a rate, and we're filling this. And remember, we have a number we're filling it by. We have 25. But think about this. After the first minute, how many gallons are in there? 25. After the second minute, 50. Remember, this starts our game of how many 25s are we going to add together? How many kids are entering this amusement park? We could add all these 25s together, or we could say the cost is 25 plus the number, or times it by the number of minutes that we're actually going to do this. Okay, so I don't suggest the add 25 30 times because we're about to do it for a half an hour. That doesn't make sense to me. That's too much math, too much work. I really want to be efficient with how I'm doing this. So now use your expression to find how many gallons of water are in the pool after a half an hour. Well, we know in minutes, that's 30 minutes is equal to a half an hour. So now we're going to take that 300 plus 25 gallons per minute, and now we can plug in our 30 minutes. And once we do that, handy dandy Desmos, 300, not 3,000, plus 25 gallons times 30 minutes, and we should get 1,050. Now, that brings us to one other concept that we do need to talk about. What was, I forgot already, 1,050. Now, I don't know if we're right or not, because does Desmos use the right steps? And in math, we have what we call the order of operations. And that's a O, not a A. You know it. Or once again, handy dandy operation. It's ER, so let's fix that. Don't be afraid of words. Use the word you want, just look it up. Make Grammarly your best friend. Or I use autocorrect in text messages. Anyways, so order of operations. We must do the parentheses first. In any problem we have, we want to do what's inside the parentheses first. So inside of this parenthesis, we just have a 30. If we had a 30 plus something or minus something, we definitely need to take care of the parenthesis first. However, if it's just a single number, we can go to the next step. The next step being exponents. Exponents are our numbers that are raised to whatever our variable. So if this was to the third power, we would want to do 30 to the third power before we go on to multiplication and division. Maybe I shouldn't use X. Let's use a dot and then the division sign. Okay. Multiplication and division are on the same level. They're on the same tier system. You can't One's not more powerful than the other, even though you say, please excuse my dear Aunt Sally. They still are on the same level. Along with addition and subtraction, they're actually on the same level as well. So how do we know what to do? Well, these ones are special, and how we do them is exactly how we read, left to right. So when we read, however we're going to read, if it was 25 times 2 divided by 3 times 70 divided by 6, we're not going to do the multiplications first. We're actually going to work straight left to right. So we're going to do 25 times 2 divided by 3 times it by 70 divided by 6. Like you're just going to work through that problem left to right as how you read it. Okay? Then once we do the multiplication and division, then we can go on to that last step and do the addition and subtraction. Now, when I said, does Desmos know this? I don't know, but let's double check. So let's do 25 times 30 because multiplication comes before addition. Because we have a multiplication here and then we have an addition here. So we don't want to do 300 plus 25, then times it by 30. We have to do this 25 times 30 first. So 25 times, 25 times 30, and we're going to get 750. So this is going to give us 750 plus 300. If you do 7 plus 3, we get 10, still have 50 left over, and we show that both of those are the same. So we know that Desmos does follow order of operations when you type some stuff in. Don't always request or fall back on that, but just know. So that 1050, and we could have done 300 plus 750 and still get that same answer either way. So it is doing that multiplication. Now, if the problem gets too complex, I don't know if Dandy Desmos will take care of all that, but hopefully it will. All right, so that gets us through our 2.1 modeling with expressions. So good luck. If you have questions, please make sure you ask. Don't sit there not understanding something. Make sure you ask questions, whether it's a teacher, come to the math help room, whatever you need, get your questions answered. All right, till next time, have a blessed day.